Any questions? Today is week 7, Monday. Okay. Next week will be our midterm. Okay. The more details about midterm will come forward, will be forthcoming. So I will let you know. You'll be given multiple days to complete the midterm. And it's going to be most likely going to have the weekend like usual. You're going to have the weekend to do the midterm exam. I'll have more details that I'll report to you. Okay. If you don't have any questions today, of course, we have done ArcCosine last week. And this week, we're going to complete ArcCosine, arctangent, and summarize, and hopefully we'll wrap up trigonometry for now. So we completed the entire basic 1 table. And of course, we have also touched on many different areas of this, of the notes, okay? This part we're doing here is very, very important. Okay, so I'm asking you guys to have your paper pencil with you and do it along with me. Please. Okay, I have investigated, I have done some investigation too. I don't know about you. When you guys, those of you who taken trigonometry, did your teacher go in the details about the ArcCosine as much as we do here? The answer may be mixed. The answer may be mixed. The truth is that if if your teacher did, that's great. But if your teacher didn't do it, it's not their fault either. Okay, because they may not have enough time to do it. Okay, as a student, you are often, I would say, you are always expected to do a lot of work that was not completed in class, and will ask you, they ask, teachers typically ask you to do the rest. And I realize a lot of our students actually don't do it for one reason or another. And of course, you always have reasons for not doing it. But the consequence can be very severe if you don't. Number one, that those unfinished business or business that cannot be finished within the given time will come back to you in the form of homework or in the form of questions on the exam. Okay, so what we're about to do today, just like what we did with ArcCosine, that whole journey of the making of ArcCosine, I want you guys to be very much involved. I don't know what you guys are doing on the other side. I really don't know, okay? And there's no way I can, well, I trust you guys are adults, but I cannot emphasize enough that you follow, you work with me in the process. Okay. By the time you're in calculus class, your teacher for sure, they will not have time to do it. They will not have time to do this. And you're expected to know so much before you can, you can secure your good grade. All right. But anyway, without further ado, I just want you guys to be really involved. All right. So to study ArcCosine that we understand, right? This function, first of all, let me put this away, right? I'm going to put this away. Okay. We understand that a cosine, okay, cosine function right here. Okay, this curve. Right? We have talked about how we got it. What's the meaning? What's the interpretation? If you don't remember, you should go back to review. It's not about memory, it's about understanding, right? So we got this curve. And apparently this function is not a 1-to-1. It does not have inverse. It will never have inverse. It never had inverse before. So we know the idea to create and to secure a function that has inverse, which is to create a 1-to-1 function. Okay, so the idea is to create a 1-to-1 function. Okay, this new function we call g. Okay, g. This function is going to be based on cosine x. Okay, as you have seen, the method is similar to what we did with the sine. Is that we're going to have a limit, we have an interval. On this interval, g, this cosine x, there's a piece of this function that is 1 to 1. That is 1 to 1. Okay, so in order to see well, right, how this function is created, and we look at these different pieces, right? We look at these different pieces. So from this is the highest point, and that is the lowest point, right? And there's another lowest point right there, right? Between these highest point, between the adjacent highest point and lowest point, these pieces, this piece is 1 to 1. This piece is 1 to 1. And these pieces is 1 to 1. The selected piece to create g function is this piece. You can see it has the range between -1 to +1, and has a domain from 0 to somewhere, okay? And how about the rest of it? The rest are being truncated. They're chopped off. These chopping, the movement of chopping, is very easy to do it, to be done on graph. But what is the implication algebraically? That's something we need to explore. Okay, so as a result of this truncation, we're being left with just this little piece. Okay, just this little piece. So what's the description of this piece? Okay, so what I'd like you guys to do with me is focusing on this little piece. What I'd like you guys to do is I want you guys to use the unit circle to mark the highest point and the lowest point and some points in between. And of course, we chopped off these pieces. These pieces are gone. These pieces are gone. Okay, so we're going to talk about the implication. So as a result of this truncation, truncation, I'm going to establish a new curve. Okay, this new curve, now after truncation, we got this new curve. Okay, we can only do this manually. Right here. Okay, this little piece, okay, about cosine. And I'm going to make it color of green. Okay, make the color of green. And then for you, okay, we're going to work together. First, we recognize that this function is between, it looks like it's between 0 to pi, right? It looks like it's between cosine x. So this is going to be our g of x, okay? And a lot of you probably have looked up x is in, okay, this little symbol is read as in or belongs to, okay? X is in this interval from 0 to pi, okay? What does it mean? The input is from 0 to pi. So this piece, okay, we truncate it and we get this piece. And next, we're going to mark some points. We're going to mark these points, okay? So everybody's going to work with me. Please have your paper, pencil. All right. So what I like to do is that I'm going to bring back the unit circle with us. We're going to bring back the unit circle with us. Okay. Let the unit circle help us. Okay. Let the unit circle to help us to identify some points, especially those special points, right? So what are the easiest points to identify? The easy points, of course, is the highest point and lowest point. We know the red numbers are for cosine, right? The red numbers are for cosine. If we limit, well, let me see. I try to include some more things here. Let me include this interval here, right? So with that said and done, okay, with that said and done, we're looking at this piece of the curve from 0 to pi, okay? And we're gonna mark the points together. We're gonna mark these points together, okay? So there's a highest point and there's a lowest point. So what are these points? And this is, of course, is a cosine curve. What are these highest point and lowest point? Anybody? Are you guys awake? Are you guys awake? The highest point and the lowest point. Can you mark these 2 points? It's a cosine between 0 to pi. The highest point is 0, 1. Very good. And what is the lowest point? The highest point, you can see the input is 0. The input is angle, right? For cosine, input is angle. Okay, for cosine, input is angle, right? So these two don't talk to each other. Okay, so hold on. Let me just mark those points on the picture. Okay, the green dots. To have the green dots, right? That's the highest point and the lowest point. Wait, green dots. Okay, these two dots. The first one, you need to understand the input is angle. The input is angle, okay? The input is angle. So this angle, how do we measure the angle? How do we measure the angle? ARD, right? ARD. So when we measure the angle, right, we get ratio. We get ratio. So when we have the angle equals 0, how do we measure it? We measure from the standard position, right? We measure from the standard position. Let me use the wrong color. Let me use a green. Okay. So we measure from the standard position because this angle is 0, so we stay there. The terminal overlaps with the initial line. So this is the angle. And we pick a point on the terminal side of the angle. Remember, I'm citing definition. And the point I pick is 1, 0. So this point I pick, the red number is x over r. That's going to be equals the ratio equals to 1. So this point, okay, so this point, okay, this point is marked as 0 is the angle. It's also arc length because the arc length corresponds to the angle. Remember, we use orange color for the arc length, right? And the red number is the sine ratio. Okay, input, output, input angle, output ratio for cosine. So what is the lowest point? What is the lowest point? The lowest point, apparently, it's -1. as the output, the -1 as output. Which number on the entire unit circle give you a -1 in red? Which angle would that be? Which angle is that?
Pi.
Pi, that's right. So you measure from the standard position, pi. Of course, it could be -pi, right? But we didn't use, -pi was not in the picture. -pi was not in the picture. -pi will be to the left of, the y-axis, right? So we have the choice we have here is pi. So what will be this point? At this angle, the entire arc length, what will be the entire arc length? This will be the arc length. Remember the making of the curves? This is the arc length. Okay, and we stretch straight the arc length, which is pi. And the red number is what? The red number is what? The red number is -1. Okay, so this lowest point, what is the lowest point? What is the lowest point? Can you guys mark the lowest point? Can you guys mark the lowest point? These actions, these exercise we're doing here is so essential. Okay, a lot of the mistakes I saw in our students, when you ask them these basic functions, they basic details, they don't know. And that's the root cause. That's the root cause that you lose points left and right. Okay, so I see an answer on chat. Pi -1, perfect answer, very good job. Okay, so this point, you see pi -1, you measure the angle, it's ARD. You guys see that? The moment you forget about ARD, the moment you're gonna start a tons of mistake. Guarantee. Okay, you measure the angle, right? You stretch it straight, that's the pi. Why do you think I use the color brown, orange here? Why do you think I use this color? Because I want you to make that connection to the lectures we did a few weeks ago. Okay, when I can, pi. And the output, right? By definition, cosine is a ratio of x over r. The red number divided by r is 1. Therefore, -1 divided by 1 is 1. It's just definition. You constantly work around these ARD. The red number. Very good job. Okay. So now let's mark a few more points. Let's mark some more points, right? For example, okay, this piece is to review the meaning of a sine curve, of a cosine curve. This piece is to review the meaning of a cosine curve. So when the angle, right? When the angle is pi over 3. When the angle is pi over 3, what is the cosine of pi over 3? What is cosine pi over 3? And that ratio everybody knows, right? Okay, you don't have to know. Okay, you don't have to know. If you don't know, that's no big deal. But you need to know ARD. You need to know how to get it. Okay, we need to know how to get it. So pi over 3, for pi over 3 as input, right? For pi over 3 as input, what do? We measure from the standard position, pi over 3 is a positive angle, counterclockwise, and this is the terminal. On the terminal, we pick a point, definition. Okay, the x coordinate divided by the radius. So here the red number has given us, okay, this is, a lot behind us, behind what we have studied, -½ So this value is -½ And on the cosine curve, what's the correspondence? The orange color, okay? Measured from the standard position, this arc length stretched straight.
Professor, is there a typo for cosine pi over 3?
Oh yes, I do have a typo. It's a +½ I'm sorry. Thank you.
You're welcome.
So here we stretch it straight, okay, pi over 3. Pi over 3. So this orange color and this arc length are the same. They're the same measurement, okay? And what is the red number? The red number is half. That's the relationship. Okay, so that's our review. This is the review. Do you guys understand? Does everybody understand? So this comes many points. And now we limit our work between 0 to pi. 0 to pi. So our orange measurement is always between 0 to pi, right? We did 0, we did pi, and we did a pi over 3. Okay. So next, I want you guys to work out a table and go through this process all over again. Are you guys with me? So let's go. Are you ready? Did you write this down? The arc length is this same orange, and the half is this red number. Okay? Because we limit our angle from 0 to pi, what is the consequence? Algebraically? When we measure our angles from the standard position, if we only measure up to pi, we cannot go over pi. What will happen? The third quadrant and the fourth quadrant become our no-flight zone. No-flight zone. You cannot fly over. Okay, you cannot say, hey, I'm gonna fly over. Fly over very quickly. No, we're gonna shut you down. Okay, I'm gonna shut you down. No, you can't. Okay, so this is our situation. You can see the implication of limiting the angle from 0 to pi is telling us what? You cannot go around and round anymore. Okay, you cannot go around and round anymore. All right, so what else? You cannot use quadrant 3 and quadrant 4. No quadrant 3, quadrant 4. Okay. And the red number, you can see the red numbers covers from -1 all the way to +1. Just like sine, right? Sine, you look at first quadrant, the fourth quadrant. Where for sine is the first and fourth, right? For cosine, it's not the first and fourth. It's the first and second. Right? Why first and second? Because if you still do first and fourth, and cosine will not have inverse either. Right? That's a common mistake. People say, oh, I know sine, arcsine is going to be between -pi/2 to pi/2. Therefore, cosine is going to be, between -pi/2 to pi/2. Wrong. You set yourself up for losing a lot of points, losing a lot of points. Okay, so did you guys write it down, this piece? So now our no flight zone is third quadrant and the fourth quadrant. They're down, they're gone, they're gone. Okay, now we're gonna set up a table. This table will allow you to do what we just have done over and over again. So the first table I'm going to give you is this guy. Okay, so let's work on the first table. Hold on. Let's work on the first table. I'll make it a little bit larger. Yeah. So your job, your task now is to complete the table, right? We have already done the first point and the last point, the highest point and lowest point. We done a point in between. So next, you guys know what to do? Do you want me to do another example? Okay, so let's go. We can have a breakout room if you wish to work with Farouz. So what you need to do is that you're going to calculate a cosine. You can use a unit circle, use whatever. Okay, I'm not even against using your calculator. Okay, but you need to give me the precise value. Precise value. Remember, your professors, your math professors want to see the precise value whenever possible. Okay, you understand, right? You understand that they just like that. Just like that. So that's why we choose choose the special angles. So what you need to do is that you're going to follow these examples and do the measurement, do the ARD, and mark the points on the curve. Mark the points on the curve. For example, with this example, right? I will be doing the terminal. Right, so I'm going to send an example for you, make the example available to you, visible to you. So measure, right? Orange, the orange color, the arc length. Okay, and your arc length straighten up. Okay. And the red number, all these effort we're making here, we try to help you to understand. Understand is a goal. You guys are you guys with me?
Not memorization.
Not a memorization. No one wants to memorize all these things in math, including myself. Memorizations will make you very frustrated. And you're never certain you get it right or not, right? I've been there, I know. Memorization is not the way to learn mathematics. Understanding is the only way. Okay, so now that you mark this point, how did I mark the point? The orange, right? This point is pi over 3, comma, the red number is half. Is that red? Is that red? Okay. Okay. At that point, we already did, right? So let me do it again. So I just want to make sure you guys understand the task you have at hand, okay? So 0 is the orange and 1 is the red number. And the lowest point here, the orange color is pi. And the red number is -1. Okay. So do you think you understand the whole story? So let's go. So you guys are gonna do is you're gonna fill all the blank and mark the points. You don't have to be precise. The point doesn't have to be precise, okay? Approximately, but that's why we mark the point. Marking make it perfect, okay? Marking the point make it perfect. So I'm gonna set up the breakout rooms. Voluntary, self-selecting. If you stay with me, I'm going to be just a little bit behind you. So you're going to start a little bit ahead of me, and you're going to do these basic movement. And Farouz is ready to work with you anytime. I'm going to get something to drink, okay? I'll be right back. All right, how's it going?
It's going well.
Very good. Just be patient with ourselves. If once we do this groundwork, we finish this groundwork, you can go anywhere. You can go anywhere. Okay. And these exercise we have done here, okay, is equivalent to many exercises that's in the trig textbook. Okay. This is they may not show up in the sections. They show up in the exercise section. Okay, we just put them all together. Okay, so this is the cosine function. After we have restriction on the domain. Okay, just let's wait a little bit. Okay. Okay, so they're back. Excuse me. All right, thank you, Farouz. I hope I didn't close too soon.
That was right on time, Professor. We finished.
Oh, thank you.
Thank you.
Right. Good job. Didn't they do a great job? Or what, right?
It's the beginning of the 7th week, Professor. We are catching up with your language, high-level math, terminology, vocabularies, visualization, unit circles, all those things.
That's right. We're laying the foundation. This foundation is very much needed. Okay, so you talk about that if you had a trigonometry you forgot. These exercise, refers to many exercises that you might have done or you would have done in a trigonometry class. Okay. Anyway, without further ado, after we have done these points, we realize yes, this function is 1-to-1. It has the inverse, right? And the domain and range. What is the domain and range for this cosine function? When we look at domain and range, there's another perspective I wish to give you, is that if you look at this, the curve, right? This curve, if you see this curve is in a box, right? From the lowest point, the highest point, right? From the lowest point and the highest point. And leftmost, rightmost. What is the horizontal span? What's the horizontal span? The horizontal span is from 0 to pi. You see, from 0 to pi. You guys see that? From 0, because horizontal span is about the input. The input is from 0 to pi. You see that? How about the output? The output is from -1. You look at the second number, from -1 to +1. If you look at the unit circle, you look at the red number, right? It's from -1 to +1, all covered. You see that? Do you see that? Right? It's all covered. And that function, the domain is from 0 to pi and the range from -1 to +1. But this function is really just a bridge. This function is rarely used because whenever cosine function is mentioned, it always refers to the cosine with all real numbers as a domain. Do you guys follow me? So you should never ever confused, because the cosine or sine mentioned always refer to the cosine or sine with all real numbers as domain, unless otherwise specified. What do I mean by unless otherwise specified? This is the situation that's otherwise specified. It tells you A is from here. If this is not mentioned, it would refer the entire number line. You follow me? So by default, unless otherwise specified, the sine, cosine, tangent, cotangent, secant, cosecant, their domain and range are referred to, they are natural, or some people say original. The domain range we talked about before. Okay, no questions asked, because if they meant otherwise, they will tell you. If they didn't tell us, then you just assume the domain is all real numbers for cosine. Got it? Now, with that said and done, we know that this cosine has the inverse, right? Cosine, okay, with x in 0, pi is a 1-to-1 function. It has a unique inverse. If we call this cosine G, its inverse is G inverse. It's G inverse. So this function has inverse. So the arc cosine we're talking about, okay, the inverse of arc cosine is this guy G. Is this little piece? Is this a little piece? You follow me? You guys follow me? So now with the understanding of arc cosine, okay, we have marked these points, right? We mark these points. We're going to construct the arc cosine table. We know that cosine is basically from angle to ratio, right? Arc cosine is doing what? It's from ratio to angle, So with that said and done, we can literally construct that function. So did you guys write this down? I'm going to clean this up. Okay. So if this is the function, right? It goes, okay? It goes from angle to ratio, right? It goes from angle to ratio, What happened to its inverse? What happened to its inverse? The inverse will make another table. Okay, let me see how many rows I should have, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So we're going to have 11 rows, right? This new function is going to be the inverse function. So this is G. We used A, so we're going to use A. Okay. And now the inverse of G, we are constructing it. This function, before we give a name, we already know its domain, we already know its range, don't we? Do we know the domain and range of this function? Of course we do, right? If the function G, right? If this function G, the domain, right? So here's the domain. And what's the range? Tell me what's the range? -1 to +1, right? What is the inverse? We call it whatever. Right? But now, what will be the domain for G inverse? Anybody has any comment? So this domain is go to the range, and the range goes to the domain. Yes? Huh? Do you follow me? Isn't that inverse function? Any pair of inverse function always, 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 forever have this feature. Okay, they forever have this feature. Now, with that inverse said and done, the inverse, what does the inverse function do? The inverse function takes ratio as input. Okay, go through that inverse function, G inverse. Okay, we're gonna give a name in a minute. It produces angles. And where can this angle be? The angle can only be from 0 to pi. Can only be from 0 to pi. And the pair, the ordered pair would be ratio. Can ratio be any number? Can ratio be any number? Ratio is input. The ratio must be between -1 and +1. You see, all of these just fall in places, right? They fall in place. Does everybody follow me? And of course, now it's time to give it a name, right? There are two names for it. Okay, this is one name. The other name is a cosine inverse. This is the way it's been written. Lately, it seems that this latter name, it has gained popularity. This name has given popularity. And because of this popularity, a lot of our students think that this function is the same as 1 over cosine. Okay? A lot of functions think this way. Sine inverse, I put this as one of the exercises in your quiz number, whatever, quiz number 14 or something. People think this way. These are those horrible, terrible mistakes that bewildered so many teachers. Where do we get this? Huh? These mistakes is not only seen by us, the lowly, community college professors. Professors at USC, they saw this mistake. Professors at UCLA, they saw these mistakes. Okay? Terrible, horrible. I couldn't say enough words to just to give you an impression that don't you ever make these mistakes.
Professor,
This guy, sorry, go ahead.
These mistakes worth -5 points, not even 0 points.
Absolutely. If I see them, I would just give them -10. Right? Right, Farouz?
Yes.
I tell you, these mistakes drive the professors, some of the professors I know at USC, crazy. How come? How could I still make these mistakes? And you see some of these mistakes actually show up on quiz number 1, right? On quiz number 1. Seemingly, I would say, I don't think that students are trying to annoy the professor to do this. It seems to be rather intuitive for the student to do so, actually. Okay? I say this with much empathy, This shows no understanding of trigonometry. The professor would be asking the question, did the student ever take trigonometry at all? So you can hear both sides of the story, right? From the student side, the students think, oh, it's rather natural for me to do this. From the professor, it drives them crazy. And of course, You suffer, the students suffer the consequence, right? What consequence do you think the students suffer? Farouz just mentioned, -5, -5. Okay. Common mistakes, common mistakes. Okay. All right. Without further ado, so let's do the work. Let's do the work. To do this work, there are two aspects. There are two aspects of it, right? One is I want you guys to practice using these notation, Okay, using these notation. Number two, you're gonna see the inverse, the effect of inverse. What's the effect of inverse? Is input output swap, right? Remember when you try to find inverse x, y swap, right? What is x, what is y? X the input, y is the output. When you swap input and output, that's how we create inverse. You guys understand, right? We emphasize this from the beginning. It is still the same thing. Mathematics, if anything, it has to be consistent from beginning to end. In the future, if one of you or some of you, going to study PhD in mathematics, you're going to see this consistency continues for eternity, And all of these consistencies is designed in every modern machinery, every device we sent to Mars, to Moon, to Pluto, to wherever. And it's being accepted by the international communities all over the world. Right? So these are the rules you're learning here. These are the rules you're learning here. Okay? All right. Look at the first one. The first one, that input was 0, the output ratio is 1. So if we swap it, what happens? The input is 1, the output should be what? Input should be 1, output should be 0, right? So ArcCosine 1 equals to what? ArcCosine inverse 1 should equal to what? 0. You guys follow me? You guys follow me? How about the next point? Now, how about the next point? Input angle, output ratio. Angle ratio. Its inverse function, what happens? Input, output swap places. So as a result, what do we get? I want you guys to write this down using your paper pencil on your paper, please. As I mentioned, why do I insist on typing these things? Because I don't want you to have any ambiguity because of my handwriting. So you will write down these word for word, okay? So when we swap input and output, what will be the output for ArcCosine √3/2? Input, output swap places, so the output will be what? Pi/6. Okay, Pi/6. From the unit circles perspective, right? So let me look at the unit circle. Let me show you the unit circle perspective. Well, maybe we shouldn't be doing so much at the same time. Okay, so let's complete the table. I'm sorry. Okay, so let's complete the table. Just do the swapping of input output. Okay, just do the output, the swapping of input output. Do you guys know what to do? Can you do the rest of it? Swapping the input output. Everybody, please do that. Okay, I want you guys to see the process. I want you guys to see the process. Okay, the input becomes output, sorry. Input, output swapped. Input output swapped. Okay, do you guys see that? Input output swapped. Notation, notation, notation. Notation, notation, notation. Okay, root 2 over 2. Root 2 over 2. Arc cosine half. Cosine inverse half. Okay, that should equals to pi over 3. We did that point, right? But now it's reversed. Reverse the input output. Reverse the input output. So arc cosine 0 equals to cosine inverse of 0. These two notations are used interchangeably. Makes no difference in meaning. Okay, makes no difference in meaning. Are you guys writing them down and look at this, you know, let's just go through them. Okay, let's go through them. Arc cosine negative half, right? Input becomes output, output becomes input. Okay. Cosine inverse.
Professor, I copied the table on my board. If you would like, we can have a breakout room or not.
Okay,
Your
yeah,
choice.
if you want, if you guys want to go to the breakout rooms, you know, we'll probably pretty much do the same thing, but you know, sometimes it's always helpful to listen to listen to comments from a different perspective, right? For example, even myself, I you know, if you listen to my past lectures, the perspective may be slightly different, even though we can talk about the same thing. All these learning experiences enhances, okay? So I've opened the room. If you want to go to Farouz, and feel free to go there, okay? So arc cosine, this is negative root 3 over 2. Write them down correctly. To tell the truth, I actually have the handwriting version. I have a projector. I can write it by hand, but I just feel my handwriting is not clear enough. Okay, so that's why I didn't use it. Arc cosine negative root 2 over 2. It's not about memorization. It's not about memorization. It's about understanding. If you have any questions, okay, so please feel free to ask. I'm here for you. Okay. Swapping the points, swapping the points. Right, input becomes output. So I'm going to swap the points. The input, it was output before. The output is pi over 6. Input, output. Root 2 over 2. All right, guys, hard work, lots of work, right? Reflecting, all we're doing here is just swapping XY, right? That's the essential step to find inverse function, right? So that step not only reverse input and output, it reverse every point. It reverse every point on the input output. Thank you, Farouz. I appreciate your hard work.
You're welcome, Professor.
Okay. So you can see that remember that's a two-step, remember the two steps we're looking for inverse, right? What did we do? We swap XY. The implication is that all the input output swapped places, and we're only just doing several of them. We're only just doing several of them, okay? And next, I wish to give you guys a break. Okay, take a break after all that hard work, and we come back. We're gonna plot the points. Okay? And so with all of these, right? All of these points we have done, right? All of these reversal. Did I make any mistake, Farouz? Okay, so let's take a break.
I'm going to look at it during break time, Professor.
Okay, thank you. You should take a break, okay?
Okay.
And I already checked. I think I should be fine, but you know.
I just didn't want to answer it unless I check it, make sure you count on me then.
Yes, I'm counting on you. If I made a mistake, it's your fault.
Yes.
So mean. I can be meaner, you know. I can be meaner. But anyway, let's take a break. Come back at 12:30. Okay, come back at 12:30. We have a longer day today. Okay, we have until 1:20. Okay, so that's why I want to give you a break for now. Okay, so back at 12:30. Okay, thank you guys for you guys' hard work. Okay, we'll be right back. Stay tuned. Let's resume recording. So after we've done this point with all these points, what do we do next? We're gonna plot them, right? We're gonna plot them. We have plotted some points. So let's start from the simplest, right? So we're gonna plot right now because we already have the cosine, right? We already have the cosine curve. So naturally, we're gonna plot the other points. That's on the inverse function. Okay, so I want you guys to roll up your sleeve with me, right? Roll up your sleeve with a paper pencil. Let's go, right? So we start with 1, 0. Okay, so we're gonna use a red dot. Okay, red dot. So what I would like you to do.
Professor,
right?
sorry.
Yes.
Sorry about that.
No problem.
I find a typo. You asked me to check the table.
Okay, thank you so much. What is it?
Maybe students can find it as a challenge.
Anybody found my typo?
Based on the domain and range, what type domain we should expect to have, what kind of range we could have, right away they can identify.
Domain range for what?
Is
For the ArcCosine.
for -1/2?
Where is it? Here?
Or
For
no.
-1/2?
Where is it? I don't see it. I'm
I guess
blind.
Riley is answering it. Yes, Riley, go ahead.
Go ahead, Riley. You want me to give you the control?
X and Y are reversed.
X and Y are reversed. Oh, here, right? Is that what you're saying?
You got it.
Okay.
Yes.
Thank you. Good job. Yep, that's a critical mistake. Thank you for telling me. Did I make any similar mistake? I didn't swap that one. Thank you very much, right? You can see everything is swapped, right? Every point is swapped. That's what we are doing here. If I swap all of them and just one, missing one, that's not gonna make it right, okay? Thank you, Riley. Okay, so we just plot 1, 0, right? The input is ratio, the output is angle. Input is ratio, angle, right? So that's a big difference. That's a big difference. So now on your paper, I wish you guys to mark this way. Okay, I have some limitation because I always have to constantly making adjustment, right? It's not I cannot do it. I can do it. It's just this time it's going to be the red number. Okay, the red number 1, the orange color, which is the angle. Okay, do you see? It's a little kind of hard to see, but red number. So from the perspective of unit circle, if we did the first table is ARD, right? Right? The first table is ARD from A to R to D. The second table, what do you do? On the second table is DRA, right? It's DRA because, for example, you know the ratio is √3/2, right? So you know the ratio. We know the ratio is √3/2. So you look for that √3/2, which is a red number, right? Which is a red number. You from the ratio is defined by definition, right? So from that ratio, right? From that ratio, √3/2, and we look for the angle. We look for the angle, don't we? So that's DRA. You guys follow me? But the A for ArcCosine has a restriction. The range is mandated. Okay, the range is determined by us. Well, not by you or me. It's determined by the first mathematician who set up this rule, being accepted all over the world. Okay, that range has to be between 0 to pi, which we will cross out the third quadrant and the fourth quadrant. Got it? And if you look at the output, right? We're about to plot the point. If you look at the output is 0 all the way to pi. So the output for ArcCosine, okay, the output for ArcCosine, what can we say? Okay, I'm going to give you this inequality. The output for ArcCosine is always between 0 and pi. In other words, the angles for the output for ArcCosine is always measured counterclockwise, right? Because you don't see any negative angle in the output, do you? Right? Are you guys with me? For example, okay? Suppose I grade a student's paper. Right? A student's work. Okay, so this student goes give me cosine inverse negative 0.35 equals to negative whatever, negative 2.3 or something. Normally, if I grade this problem, I will have to check the calculator, right? cosine inverse of negative 0.35. And I will need to check the calculator. But in this case, I don't need to. The student doesn't get any point. Are you with me? When I see this, okay, I don't need to check anything. I'll just give the student 0. Why? 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 Because arc cosine, which is a cosine inverse, is always between 0 to pi. It will never equals to a negative. This negative sign tells me the student gets 0 for that answer. Are you guys with me? That's how important the range is. Range tell you what to expect. If something is not expected, you get 0. That's the nature of range. Range tell us for any specific rule, the range of the rule, we know the rule is a function, right? If the rule is a function, if that rule has a range and you are outside the range, you get 0 because the rule says so. The rule tells us what to expect. That's the power of range. That's a powerful range. Okay? Now, without further ado, let's go back. Okay? So let's plot the points. We just plotted 1, 0. Now, next, we're going to plot this point. Red dot. Oops. Red dot. Red dot. Okay. And the next red dot. Can you guys do this with me? On your paper, please. Red dot. Okay. And let's see. Where are we? 1, 2, 3, half. Did I do half root 3? No, not yet. Half root 3. Red dot. Half root 3. I think I already did it. No, wait. Half root 3. Pi over 3, sorry. Okay, so you guys are gonna plot one after another, okay, on your paper. Okay, the next one is 0 pi over 2. Red dot. Now the point is outside. It's outside, right? I need to make some adjustment. To my picture. Otherwise, you don't get to see the points, right? You don't get to see the points. So 0 pi over 2. Where's my 0 pi over 2? Add the dots. 0 pi over 2. It should show up there. Right? Very good. Okay. So keep going. Everybody, please, you plot these points. Okay. Please plot these points. All of them. And we're going to mark them together. We're almost done. Last one. Red dot. -1. Finally, look at that. That's the arc cosine. You can see the entire curve is above x-axis and touching x-axis only once, right? It's above. This also show you the red curve. The red curve is what? The red curve is non-negative between 0 to pi, between 0 to pi, okay? This little piece, I cannot get rid of, okay? As I said, there's not a function that will plot this special cosine. No matter how I manipulate the software, I cannot make that happen. So I'm gonna just cross it out, okay? I'm just gonna cross it out. So next, we're just going to connect the red dots, okay? So let's connect the red dots. So that's easy. I simply have to enter arc cosine. Okay, I make it the red. Boom. That's arc cosine. That's arc cosine. Shall we mark some points? Shall we mark some points? How about you guys start marking some points? Okay, let's mark some points. I'm going to give you a picture because between the classes, I was working on this picture to make it nicer, right? To make it nicer. So this is also part of your homework. Okay, this is also your part of your homework. So I use another software that, created, that's, okay. I mark some points and you're gonna mark the rest of the points. You guys know how to mark them, don't you? On the red is the arc cosine. The green is the cosine, which is between 0 to pi. Okay, so it's been marked 0 to pi. Okay, so let me make this picture. Can you guys see this well? Can you see this well? Because I did some copy and paste and snipping and all of that stuff. And I hope it doesn't lose too much. Okay, the red dots are on the red curve. The green dots are on the green curve. So these are the two functions that are inverse to each other. Okay, these are the two functions that are inverse to each other. This is the pair that inverse to each other. Okay, so your task is to mark all of the points. This is part of your homework. If you guys don't have any questions, we're gonna move forward. We're gonna move forward. All right, so next, we're gonna get to the other interesting property, okay? Remember the other interesting property that we also applied to sine and arcsine, right? Which is this guy. Okay, so let's do a little summary. Okay, the function we talk about, g equals to cosine x, where x is in the interval between 0 to pi. Okay, we know its implication, right? The no-flight zone. The range of cosine, of course, is still between. So let me make a table for the summary, okay? The g function, right? The g function is here. The domain as such Okay, we did all those points. And the inverse of G is arc cosine of X. Okay, so let me make it 175%. So this number is not consistent. Sometimes it doesn't show the negative sign with smaller fonts. But anyway, and we understand that the G inverse it takes ratio as input, right? The arc cosine or cosine inverse, same thing. It produces angle. But the ratio cannot be any ratio. The ratio has to be what? The ratio, which is a domain for arc cosine, the ratio has to be between +1 and -1. Okay, and the range, right? The range, so domain and of course is this guy. I can put it here, right, for simplicity. And the range for arc cosine is that between 0 to pi. Okay, and I wish to give you all the other algebraic forms, right? The input must be between -1 to +1, and the other form would be the absolute value of X must be less than or equals to 1. You need to be able to recognize all three, okay? So the range for cosine will be between 0 less than equals to arc cosine X less than or equals to pi. That's the inequality. Okay. For cosine, of course, is still taking angle produces ratio. Okay, for this particular for cosine. Okay. Produces ratio. Okay, what kind of ratio? Defined in the definition. Okay, the definition in the definition, of course, is X over R, right? We have that stage set and all of that. Domain wise, okay, domain, of course, X belongs to 0 to pi. Okay, and the range, what would be range? -1, +1, and there are other forms, right? -1 less than equals to cosine X, less than equals to +1, or, so you had these forms before, okay, I'm just repeating them. They are super useful. So these algebraic forms are super useful, These two functions are inverse to each other. Then how about the cosine X? The cosine X we refer to, of course, is still from angle to ratio, but that domain is all real numbers. Okay, that domain is all real numbers. And the range, all these three forms, no change. Okay, all these three forms. So when we, in your life, in your academic career, whenever cosine and arc-cosine are addressed, whenever cosine or arc-cosine are addressed, it refers to this function and that function. And this function is rarely mentioned. Okay, so this function is rarely mentioned. So there should never be any confusion. R-A-R-E, rarely mentioned. You just need to know that these two functions, they're not inverse to each other. They're not inverse to each other. That inverse function is hiding. If that is referred to, it will be otherwise specified. Okay, so now we're going to see the otherwise specified. Okay, let's look at the situation of otherwise specified. Okay, now we know these two functions are inverse to each other. We know these two functions are inverse to each other. Okay, now we know these two functions are inverse to each other. So this truth will still be true for this pair, except that we now have a pair of G and G inverse. Do you guys follow me? So now all the F are changed to G. G, G, G. You follow me? Okay, so now what has this piece turned into? The G inverse is the ArcCosine. G inverse is ArcCosine. So we can write it this way, cosine inverse, and inside the G is a cosine. Do you follow me? And X is in the domain of G. What is the domain of G? What is the domain of G? Domain of G is from 0 to pi. Therefore, this X is in the domain of G. That's what you see. You follow me? Now, G inverse, G is a cosine. What's the cosine? What's G inverse? It's cosine inverse. And what's the domain of G inverse? What's the domain of G inverse? The domain of G inverse is between -1 to +1. You see that substitution? You see that consistency, that beautiful consistency? Do you see that? And of course, we have another form, right? ArcCosine of cosine X. Okay, and this piece can be replaced by cosine of ArcCosine. So these are the two different forms. These are the two different forms. And these are the two forms you see on trig 7a, the second row. The first table, second row. First table, second row in trig 7a. Do you guys see that? Do you guys see that? Yeah? You see that? Okay. So now let's look at trig 7a. Let's look at trig 7a. So you can see these axes, right? Even though they have the same name, they're merely placeholder. They're just placeholder. This angle, this A means angle. This A means ratio. So what determines the meaning of symbol? It's determined by the function that immediately apply to it, right? Cosine function requests angle as input. If a cosine is immediately next to X, X must be angle. ArcCosine function requests ratio as input, ratio between -1 and +1. And cosine inverse function immediately act on this X input. So X will be regarded as the ratio. And that ratio has to be between -1 and +1. You can see these two properties, just like the similar two properties for sine, which is on the first row of trig 7a. They're very similar in nature. They're very similar in nature. Okay, they are all consequences of applying that property. Okay, applying that property. Okay, so without further ado, so did you guys write them all down? Yes? Next, let's look at some exercises in trig 7a. Shall we? Trig 7a. I'm going to bring these two on the top. Oops. So this is one box. And this is another box. Right? And those are the second table. Did I smell something burning? Is it from outside? Whatever. I don't think I turned on the stove though. All right. So let's look at the cosines in the table. Okay, in the table. Okay, cosine. Let's look at the cosines. Are you guys ready? Number 3 and number 4. Number 3, number 4. Okay. Number 3, trig 7a. Trig 7a, number 3. Okay. We have a cosine, arc cosine of 4/5. 4/5. Four. I should say 4 for you. Okay, let's do 7 then. Time is running out. We only have 19 minutes left, right? So arc cosine. Okay, arc cosine of cosine pi over 3. I want to show you the different ways of working these, the different ways of working this. One is that if you know these property, very well, and you're certain, okay? Because it's a whole lot to memorize. I hate memorization. I personally don't like memorization. Okay? If you have that super duper memory and you always trust your memory, right? Great. Then the second one, right? You look at these two properties and which one does it apply? Right now you have the property with you, right? Sometimes it's a closed book or these are not with you. What do? You have to have the whole process with you. You have to have the process reflected in you. Hopefully that will be, that's with you, that process, that skill of analysis is still with you, which usually doesn't make any mistake, right? So cosine, so you look at the inside, right? You always start from inside out. Because of this form it's similar to that, right? In this form, as long as x is in the domain of ArcCosine, you're set. So this answer is 4/5. It's very easy, right? So what did we apply? We applied this property, right? Applied. You're done, okay? On the second one, the first property applies, okay? Because of what? Because the input x is between 0 to pi. Pi/3 is between 0 to pi. Therefore, the answer is just pi/3. You're done. You're set. This is suppose you understood everything. You just happen to be clear about these two identities. No problem. What if you forgot? You have forgotten, or you're not sure, or this is 3 years after you know, this is 3 years. You take your calculus class, or you take whatever, 3 years after, right? What do you do? Right? For the same question, I'm going to show you how ARD-DRA applies. The use of ARD and DRA. You follow me? Which is, I hope, will always be there to help you in the case of, you know, uncertainty, in the case of uncertainty. For that one, I will go back to the definition, and typically, right, even if you don't remember the details, right? For example, in this case, you actually, it's not a special angle. So these angles are not useful. These angles are not useful. So what I would do is that suppose you don't even remember this guy. Suppose you don't even remember this guy. What do? What do you do? Well, I can always go back to the definition. I will set the stage, this definition, right? I'm going to set the stage. I'm setting the stage, right? I'm setting the stage now. Okay, so I'm setting the stage. I'm just I have my unit circle next to me. I'm sorry, it's not even unit circle. It's just a rectangular system. I'm going back to the very basic. Okay, whenever we have hardship, if we go back to the very basic, we go back to the definition, to the fundamentals, we will typically always have something that help us to get something sensible. Okay, for example, this is a question. If you look at the inside, if you look at the innermost, right? If you look at the inside, we always start from the inside. What does the inside tell us, right? We always start from the inside. The inside tells us this is going to be an angle. This is going to be an angle. This is going to be an angle with the terminal ends up at 4/5. 4/5. So I'm going to measure from the standard position, counterclockwise, ArcCosine's value also between 0 to pi, right? So the angles will always be in this range, 0 to pi. And because it's a positive ratio, so I'm going to end up somewhere like 4/5, right? 4/5. So I pick a point arbitrarily. You don't have to be even on the unit circle. I can be just here. Okay. And then you can draw your triangle here. My drawing is a little inaccurate, so let me do it all over again, okay? So I just want to give you a better visual, okay? So I'm drawing this triangle, right? I'm drawing this triangle, and I still have I want you guys to connect with the blue number, red number. And then I'm just going to do, this is a 5. The red is 5, right? The blue is 4. The blue is 4. And this is a question you guys are fairly familiar with, right? The hypotenuse is 5. So 4, 5, you need this skill, guys. You need this skill for Calc 2. Okay? You don't have a special angle. What do? I know ArcCosine tells me the ratio is 4/5. It's a cosine. Okay, we know the cosine ratio is 4/5. We're looking for the angle. And the angle has to be between 0 to pi. And because this is a positive ratio, so this angle can only be terminating in the first quadrant. So this is going to be my my theta, whatever angle you call it. Okay, I'm going to call this angle theta. Okay, so now I got a point on the terminal sides. Okay, there will be, and what is it? For this point, there's a red number. There's a red number. And there's also a blue number. Okay, this is referred to the unit circle you're so familiar with. Okay, and what is the red number? The red number is 4/5. Okay, and the blue number, I don't need to know. Well, we actually know. Okay, you don't need to know here. So now, so this angle is theta. So cosine of that theta will be, we're calling for the red number. So this piece, right? So whatever theta you're going to be, so this is a theta. And the answer has to be what? The answer has to be 4/5. So you can also figure out this way. Do you guys follow me? Because the cosine of that angle is a red number. And we have the red number. The red number is 4/5. So this is a typical of a DRA. DRA. You follow me? So when in times of hardship, we can always go back to the basic ARD. Always go back to the basic. And of course, you need to be aware of ArcCosine domain and range, domain range. So with that said and done, that's ARD. That's ARD. Got it? Okay. Next. Okay. The next. So this answer, from that, our analysis is 4/5, right? We go through the whole 9 yards to analyze it, right? And we also referred to the blue number and the red number, right? So the blue number, red number, or whatever color you designate it. The first number is X, the other number is Y. So whatever you do, it doesn't really matter. It's just there's a correspondence. The next one. Okay. If you don't remember the property, what do? You just start from the inside out. You just start from the inside out, right? So pi/3, you do it from the inside out. So you're going to have ArcCosine of cosine of pi/3. Cosine pi/3, you're going to do ARD. You measure pi/3 and you get the red number. So this is going to be what? This is going to be half. This is going to be half, right? You just do layer after layer. And what is ArcCosine half? What's the ArcCosine half? ArcCosine half is DRA, like just similar to what we did, right? So if you have this unit circle or not have the unit circle, you can do similar to what we just did earlier with 4/5. So in the end, if you measure that, you're gonna get pi/3. Am I too brief here, or you guys got it? There's so many different angles you can handle this. Really, there's many ways to run. There are many ways to run. Okay, but the technique I just mentioned of drawing arbitrarily, 4, 5, those are commonly used, especially when you're in calculus class, you don't always get special angles. Now, without further ado, okay, we still have 7 minutes left. Let's do some unusual situation. Let's do some unusual situation. You guys ready? I'm gonna choose a question for you. Okay, this question I choose is number 18. Number 18. Arc cosine of cosine negative 3 pi over 4. In this case, neither property applies. Do you agree with me? Because you have a negative angle. You have a negative angle. Do you follow me? You have a negative angle here. The first one does not apply. The second one doesn't apply at all. Okay, so I'm going to put a little comments here. You don't have to. Okay, doesn't apply. It doesn't apply. And what do? In this case, you can only do from inside out. Can you say this cosine is undefined? Can you say that? Absolutely not. Cosine as a function. This cosine refers to the cosine as we always know. The domain is all real numbers. So it is completely defined. Do you follow me? I'm going to show you maybe 2 ways or maybe even more ways to do this. Okay. Now, suppose you use either one, right? For example, I'm using this unit circle. Okay. Suppose you guys are pretty good at using this unit circle. Now, when we measure, so what do? You have a negative 3 pi over 4. What do? Well, you have to do it from inside out, right? So you're going to leave out the outside and you're going to work the inside. So cosine negative 3 pi over 4. So that's a typical ARD, right? So we're going to do the ARD. I'm going to measure from the standard position. And that's a negative angle. So I'm going to measure clockwise. Where do I get to? I get to here. I get to there. Right? Negative 3 pi over 4. And what's the red number? What's the red number? The red number is negative 1 over root 2 or negative root 2 over 2. Same number. Same number. And then what? Then what? Now you have a ratio for the input of arc cosine. What angle do we get? The answer must be between what? 0 to pi. That's what you need to instill in your head. So your angle has to be between 0 to pi. The answer cannot be negative 3 pi over 4. What can that answer be? Then you look for first quadrant, second quadrant. Remember, this piece, when you consider arc cosine, third quadrant and fourth quadrant are out of that's no flight zone. No flight zone. So your angle will be measured from the standard position, and you're looking for negative root 2 over 2. Where do you end up? The angle has to be non-negative, counterclockwise measurement. And here you go. So your angle is going to be what the answer? The answer is going to be what?
chat respond, Professor?
Perfect, perfect, Hazel. Great job, Kelly and Hazel. Very good job. Okay, 3 pi over 4. 3 pi over 4. You got it. Wonderful. All right. Another way to do this. I do want to give you the other way to do this. Okay. This other way to do it. Okay, this other way to do it is that you realize that cosine is an even function. What does that mean? Cosine is even. What does it mean? Cosine is even. Cosine of, remember we did a lot of practice with the cosine, even function, odd function, we did the table, right? Cosine of negative x is the same as the cosine x, right? For any x, for any real number x, of course it is true for cosine, for negative 3 pi over 4. Therefore, we can use that even function. Okay, even function, what do we get? This piece is simply just equals to if you remove the negative sign. And then one of the properties applies, and you're gonna get, because this angle is between 0 to pi, the answer is gonna be 3 to pi. That's another approach. So sometimes you can use the even odd function properties. Okay, you can use the even odd function properties. You guys got it? That's right. Opposite inputs, same outputs. That's right. Wonderful, wonderful comments. I'm so glad. You know, you're using the language. You're using the language. Okay. So we have, oh, time is up. Time is up. I think this example will be sufficient. Okay, you guys should be able to do the rest of them about cosine. So continue to work on. I'll give you guys some homework. Okay, the first part of the homework is about the, you know, the graph. The graph we spent so much time on. I want you guys to mark the points. Okay, to mark the points and reflecting on its meaning, reflecting on ARD, DRA, that sort of thing. And then continue to work on trick 7A, okay? And I will see you guys tomorrow. I'll see you guys tomorrow. Thank you so much, Farouz. Okay, you worked so hard.
You're welcome. Thank you,
to make that
Professor,
table. And thank
for
you
the class.
of course. And thank you for spotting my mistake, okay?
You're welcome. You're welcome. Thank you letting us to be
Thank you, Riley.
interacting.
Okay,
And
thank you, Riley.
Professor, for the whole class, I will be in Math Study Center from 3 to 6 if they choose to.
Wonderful. Thank you so much.
Have a good day.
You too. Very good job participating, okay? I'll see you guys tomorrow. Good job. Very good job. Thank you. Thank you. Wonderful job.